Hello and welcome to this video for CE 105205. In this video, what we are going to see is some example of how glass is used in our daily life. What are the typical application where glass plays a key role? And so based on all of this, what we will see is that glass is really playing a pretty important role in our daily life, and that it might be argued that we are presently living in the age of glass. So materials besides glasses have always played a key role in the development of mankind. And this is to the point that some ages of human history have been named after materials that have been really influential, have been enabling new development in mankind. And for example, the Stone Age, the Bronze Age, the Iron Age, those are ages where material have really played a very important role in either helping humans interact with the environments or developing tools that humans can use to either eat or fight with each other. So all of those ages, the fact that they are named after materials highlight the fact of how influential materials have been in human development. And so more recently, other types of materials have become obviously more influential. So for example, the development of concrete and steel, this is really what has enabled the development of modern infrastructure, like the ability to build large infrastructure at a pretty low price. This is something that has been enabled by concrete and steel. More recently, the development of plastic has also really changed the way we make products. And over the past decades, silicon and the ability to make chips that can be used for computers or smartphone, tablets, etc. This is really also a very new influential way of how materials can play a key role in changing our daily life. And so what we are going to see in this video is that glass also plays a very important role in society, but sometimes it's more hidden. It's more hidden than concrete, for example, or plastic, because we don't interact with glass, or at least there is a lot of application where glass is used, but in a pretty hidden way. So what we are going to do next is to review several types of application of glasses and try to understand for each of those applications what are the key characteristics of glasses that makes this material, glass, a material of choice for those applications. One first application of glass is for art. And so the reason behind this is that glass has something special, which is that first, it can be transparent. Second, you can shape glass, you can mold glass, you can have glasses with any shape you want. And you can change the color of glasses based on the chemical composition of glasses. And for all of those various features, glasses has been pretty extensively used for artistic application. So in church or in just to make object or statues, like this ability of glasses to be transparent and to have the shape that you want makes it a pretty interesting materials for artistic application. The second key importance of glasses, and this is to some extent like one of the very first application of glasses, is that they are used as containers. And so they are used to contain liquids or to isolate food from the rest of the environment. And in this case, like the key characteristics of glasses that makes it a good material to be used as container, like to be used as a regular glass that you would use to drink, is that first it has a good permeability. It's non-porous, so it means that if you hold the liquid inside the glass, the liquid is not going to go through the glass and leak out. It's also chemically inert, so it's not going to react with liquid it's in contact with. So for example, if you drink something, you don't want your glass to dissolve into whatever you're drinking. So clearly this ability to have a good chemical durability, so that it's pretty inert and doesn't dissolve or doesn't react with the liquid it's in contact with, is an important characteristics when you are using glass as a container. And the last thing, and it's especially true for example, the Pyrex glass, is that it's pretty resistant to temperature. So it means that first, if you change the temperature, you increase the temperature, you decrease the temperature, there is for at least for those types of glasses like Pyrex, there is a pretty low risk of thermal cracking because the glass does not have a very high coefficient of thermal expansion, so it doesn't change its dimension so much when the temperature is changing, which limits the amount of stress that is developing in the glass as the temperature is changing, which also limits the risk for thermal cracking. And the other thing is that you can put glass up to high temperature and it will only start to melt at fairly high temperature, at least for these types of Pyrex glass. So it means that you can use these types of glass for cooking. It can be put in the oven. It can resist high temperature in a way that other materials like plastic, for example, would not be able to. So they would start to melt or to degrade at high temperature. So glass in that respect is an interesting materials in its ability to resist heat or to resist changes in temperature. Of course, when we think about glass, we always think about windows because this is maybe the way we interact with glass, the most visible application of glasses. And if we think about it, the ability to make windows in buildings has really changed the way we live as humans. The ability to see the outside world is really changing. It's a very luxury aspect of our life that we have the ability to have windows that are made of this glass material that is transparent so that we can see outside, but still that can isolate us from the outside, that can isolate us both in terms of noise, in terms of heat, in terms of liquid. So if it's raining, you don't want rain to come inside your house. So this ability of glass to act as a material that can isolate you from the environment while still being transparent is really what has changed the way we make buildings, and that allows us to have more luxury in our life and the ability to live inside and be protected from the environment while being able to see the outside world. So in the previous video, when we discussed the natural glasses, like we discussed the fact that glasses that is found in nature can sometimes be billions of years old, especially the glass that were found on the moon. They were about 3 billion years old. And so this highlights the fact that glass is a very durable material, that it can resist the environment for a very long time. And that's one of the reasons of why glass is used to store nuclear waste immobilization. And in that case, the idea is that so all the waste coming from the nuclear industry, either from nuclear power plants or from the legacy nuclear weapons, those waste, they need to be stored. They need to be isolated from the rest of the environment so that they don't leak out to groundwater, for example. And for this, to prevent the leakage of nuclear waste to groundwater, the method of choice that is used by most countries on Earth that have some nuclear industry is to turn those waste into glasses. And the idea in this case is not to take those waste and surround them by some kind of glass barrier. It's really to take the waste, add some extra ingredients inside those waste, and then freeze them into a glass. So the waste itself become chemically part of the glass. And that's the reason why it's those types of nuclear waste immobilization glass, they are so useful and so resistant to prevent the leakage of nuclear waste into the environment, because the nuclear waste becomes chemically trapped and they become part of the chemical structure of the glass. They become the glass itself. And so this process of turning nuclear waste into glasses, it's a process that is like fairly processable, and in that sense that it doesn't require super high temperature or super complex methodology, and it's a method that is also not super expensive. So it's really the method that is the most efficient at storing and immobilizing those nuclear waste. And then the other advantage of glass, as opposed to other materials, is that so not only it's resistant to corrosion, so it means that the glass is not going to dissolve super fast if it enters in contact with water, but it's also resistant to irradiation. So it's unlike other materials that would be degraded if they're in contact with the irradiation that comes out of the nuclear waste. glasses is pretty resistant to irradiation, so it's really a good material to immobilize those nuclear waste and isolate them from the rest of the environment. Another interesting application of glasses that we don't really think about so much is bioactive glasses. And here the idea is to use glass to stimulate the growth of bones after a fracture. So if you break one of your bones, one medical option is to use glasses. And in this case, the idea is that you would place those bioactive glasses inside the human body. And this glass is going to start dissolving in your body, and it's going to release, it's going to leach out some elements like calcium that are then going to be used naturally by your body to accelerate the growth of the bones. So in this case, the glass is not used to seal the bone, it's really used to just release the chemical elements that are then used by the body to accelerate the regeneration of the bones. So here there's something pretty interesting, is that in that case, for those kind of bioactive glasses, you really want the glass to dissolve fast. Or at least you want to dissolve it inside your body. You don't want the glass to just remain forever inside your body. So in this case, it shows that glasses, it doesn't have to have like fixed properties. Certain glasses, like the one that are used for nuclear waste immobilization, you really want those glasses to be very resistant to corrosion, to be very durable. But those glasses, those bioactive glasses, you really want them to dissolve in your body. So that shows that the properties of glasses, they can change. There is not a unique set of properties. Glass is a very flexible, a very variable material. Its properties can change a lot if you change the composition of glasses. So one of the things we are going to talk about in this class is how to understand how the composition of one glass affects its properties. Like if you change the composition of the glass, how is it going to affect its properties? Like for example, its mechanical properties. Another very important application of glasses that have become very popular over the past decades is the ability of using glass for screens. And so, for example, like this is something that has really been developed a lot since the release of the initial iPhone, of the fact of using glasses to protect screens that are used for smartphone or for TVs. And we don't always realize it, but there's a lot of glasses that are used in every screen that we use, whether it's a smartphone screen or a TV screen or like a smartwatch screen. There is several layers of glasses, not just the outside of the screen is made of glass, but there is really several layers of glasses that are used to make any screen, whether it's OLED or LCD. So we'll talk a little bit more about that. So for example, on LCD screens, there's typically four layers of glasses that are used, and each of those glasses is having a distinct role. So the first one is the one we actually interact with, and we keep, to some extent, we keep touching glass all day long, since every time we interact with our phone, we touch a piece of glass. And so this glass is the cover glass. That's the glass that is going to be on the outside of the screen. And this is really the glass that is acting to mechanically protect the screen. So that's the glass that is, the main role of this glass is to be resistant to scratching and resistance to fracture. And that's the main reason of why we are using glass instead of plastic, for example, is that plastic, it's very easy to scratch, but glass is much more resistant to scratching. It has a much higher hardness. So it's a good material to use to protect like the outside of the screen. And so for this, for example, like a very famous glass is the Gorilla Glass from Corning, and that's typically the glass that is used on most smartphone or most tablets, because it's a glass that has a very high hardness and a very high toughness, so it's able to protect scratching and also ideally protect the fracture of your glass if you drop your phone. So that's the glass made by Corning that is used very commonly as the outside layer of any screen. Then you have the glass that is used for the touch sensing feature. So this is the glass that is used to detect your finger and interact with your smartphone. And then you have some glasses that are the front plane and the back plane. So those are the glasses that are used as substrates for the screen itself, for the LCD screen. So this is the substrate where the transistors, for example, or the color filter that are used in a LCD screen this is where you will deposit those electronic elements on this kind of glass substrates. And in this case, the properties of those glasses are very different. For those glasses, we don't care as much about their mechanical resistance. What we really care is first their optical properties, because light is going to go through those glasses, so they need to be as transparent as possible. And we also care a lot about their resistance to changes in temperature, because the process when we deposit those transistors onto the glass substrate, that's something that is performed at high temperature. And so in that case, we really need to make sure that the glass is going to be able to resist this high temperature without changing its dimension so much. Otherwise, if you deposit the pixel onto the glass substrate at high temperature, and then once you go back to room temperature, if the glass starts to shrink, then that's going to cause some misalignment of the pixels, for example. So in this case, it's pretty important to ensure that as you heat or cool the glass, that it's not going to change its dimension so much. So the resistance to change in temperature in that case would be a very important characteristics of those display glasses, those glasses that are used as a back plane or front plane in LCD screens. Another example is OLED screen. The main difference between LCD and OLED screens is that in LCD, you have the filters that you can activate with the transistors, and those filters are going to change the color of a light that is coming from underneath the screen. So in the case of the LCD screen, you have a source of white light that is coming from the back of the screen, and then this light is going to be going through the filters that are going to change the color by blocking certain wavelength of the light. In the case of the OLED screen, it's pretty different, because the light doesn't come from the back. The light comes from the OLED pixels themselves, the organic pixels. In that case, the way those OLED screen works is that you have those organic pixels that are going to be activated, turned on or turned off by transistors. And so those pixels in that case will emit directly their own light with different colors. And so those OLED screens also use many layers of glasses. And so we will find the same typical layers, like the cover glasses. You have the touchscreen and the backplane that is used as the substrates to deposit those organic pixels that are used in OLED screens. But in OLED screen, you also have an additional layer of glass, which is the encapsulation glass. And in this case, what the role of this glass is to isolate the organic pixels from the rest of the environments. So those pixels, they are made of organic materials. So if they are in contact with oxygen from the atmosphere, they are going to be oxidized. So those organic pixels need to be isolated. They need to be hermetically isolated from the rest of the environment to avoid being degraded. So that's the role of the encapsulation glass. It needs to be as impermeable as possible, so that there is no moisture or no oxygen from the atmosphere that is able to reach the OLED pixels. Another very important application of glasses that we don't typically think about is glass are used for optical fibers. And this is really important, because now most of today's information is going through those optical fibers. Like all modern internet, whole high-speed internet is going through those optical fibers. That's the way information is transmitted from one point to another, is by being transmitted by those optical fibers, rather than the old copper wires that used to be used. The idea of the optical fibers is it's made of a piece of glasses, like some kind of tube, and then you can have some light that is going to be transmitted through this tube. and the transmission of the light is what is going to transfer the information from one point to another. And so in this case, that really the key characteristics of those fiber optics is that they can transmit a lot of information and transmit this information very fast. And that's really why it plays such an important role in modern communication and modern internet. And in that case, the characteristics of glass that makes this thing possible is first, obviously, that glass is transparent. So if you transmit light, then you will be able to transmit light over a very long distance because the glass can be very transparent, so that there is very little loss of light through the glass, which makes it possible to make the light travel over very extended length before you need to reactivate the light signal. The other thing is that obviously it's very durable, so it makes it possible for those fiber optics to be resistant to time. And the other characteristics of glasses is that depending on its composition and depending on its geometry, so glass is typically a fairly stiff material, but in the case of fiber optics, it's actually bendable. You can take those fiber optics and bend them without breaking. And this is an important characteristic, of course, because in this case, those fibers, they are not just, you don't want just them to be in straight line. They need to have the ability to bend so that you can transmit the information not just in straight line, but with any direction that you want. So in this case, the glass that is used for those fiber optics, and due to the fact that those fiber optics are so thin, it makes it possible to be fairly flexible, like to be able to bend them without breaking them. And so that's an important aspect of glasses that are used in fiber optics. And again, it shows that glasses doesn't have to be some fixed properties. Like certain glasses are going to be very stiff, very hard to deform, while some other glasses like those fiber optics can be much more bendable, much more flexible. So if we come back to this notion of in which age, what is the key material that is really changing the way we live today? And so if we go back in time, of course, concrete, plastic, silicon, they have had some key aspects in our life. But if we really think what defines our society today, what defines our society is the ability to share information between humans and to interact with this information very easily with a touch screen, for example. And all of those things, the ability to share information using fiber optics, or the ability to interact very directly and very easily with information with a touch screen display, all of those things are really enabled by glass. So this is one of the reasons why certain people have argued that today we are living in the age of glass. So thank you for watching this video. In the next video, what we will try to discuss is how do we define glass? What could be a good definition of glass? It's actually very difficult to come up with a definition of glasses because glass can be many things. Again, glass can be transparent or not transparent. Glass can be stiff or not stiff. Glass can have different compositions. So coming up with a definition of glasses, of what is a glass and what it is not, is actually a fairly difficult process. So that's what we're going to talk about next.